everyone, welcome to Insights by Arish. Today we are going to implement a convolutional neural network project of potato disease classification, and for that we are going to make use of this dataset of potato disease dataset. Now this dataset consists of three folders. Actually, these are the three categories into which our image will fall. Either they will have early blight, late blight, or they will be healthy. So you can see you have 152 images in the potato healthy folder, then 1000 files in the potato early blight and 1000 files in potato late blight as well. So this folders consist of all the images that fall into this particular category that we are going to make use of for training our model. Now you can go ahead with two ways. Either you can download this dataset into your system and then you can upload it into the Google Colab, and then you can start building the project. And the second way is, instead of downloading it in your system, you can directly connect it from here to your Google Colab using the API token. So I will be using the second method of creating the API token. So as you can see, this is my Google Colab, and right now I don't have any folder into this particular Google Colab environment. So what you have to do, go to Kaggle and click on the rightmost top profile icon, as you can see here. Click on that and then click on settings. When you click on settings, you will get a page, and when you scroll down you will see an option there of API. As you can see here, we have two options of creating new token and expire token. So I already have created one, so I won't be creating new. But if you haven't created any token, then you have to click here on create new token. So when you click here on create new token, a JSON file from Kaggle will be downloaded to your system. So it will be basically named as kaggle.json. Now you have to upload that kaggle.json file here into your Google Colab environment. So I will just upload that. As you can see, I have uploaded that file kaggle.json in this environment. So this file is actually going to connect our Google Colab project to that dataset. So once you paste that file into Google Colab, you have to write some code in order to identify that file. So you will say make directory. This code will basically verify that JSON file, and it will make use of that in the future cells. So then you will say cp kaggle.json, that's the name of your file, and then again .kaggle. Fine, run that. And this code will only work when you have that kaggle.json file in your Google Colab environment. If you don't have that, then it will basically give the error. So before writing this code, you should have that file kaggle.json in your Google Colab environment. After writing that file, now what we have to do, we have to load that dataset from Kaggle in our Google Colab. So now what we have to do, we have to load that dataset of potato disease here in our Google Colab. So for that, we will again go back to that page of potato disease. As you can see here, we will click here on the three dots and we'll copy API command from here. Once you copy that API command, you will come back to the code, and here you will first place an exclamation mark and then you will paste that API command. The exclamation mark is very important, and then run that cell. After running that cell, as you can see, it's downloading the dataset, but it will download the dataset in the format of zip file. So I have to extract the contents from that zip file as well. So after running this cell, just refresh that environment, and as you can see, now you have this potato dataset zip file. So the next task is extracting the contents from that zip file. So we'll again write the code for extracting the contents from the zip file. So first we will import zip file. After that, we will say zip underscore reference is equal to zip file dot capital zip file, and here you have to paste the path of your zip file. So go here and just copy the path of your zip file and paste that path here. After pasting that path, then you have to open that in reading mode. So R, and then zip underscore reference dot extract all. So you basically have to extract all the contents. So extract all, and here you have to paste the path where you have to extract the contents. So this is the path from where you are extracting the contents, and this will be the path where you have to extract the contents and keep them. So I have to extract the contents into this environment only. So what I will do, I will just say here contents. content. So this content basically means after extracting all the contents from this path, it will store that extracted content here in this environment. Then I will close that zip reference dot close. Run that, refresh the environment, and you have that 3 folders from the Kaggle: early blight, late blight and healthy here in your environment. So now we have extracted the contents from the zip file successfully. After that, now we will import all the necessary libraries that we require. So let me close this. So here we will import all the necessary libraries. Let me name it as importing libraries. Then here I will first import NumPy as np. Then I will also import matplotlib. After that I will import OS. OS will basically help us to join the path and get the path of the images. Then we also require CV2 for some image processing part. Then the basic core part, that is TensorFlow. So import TensorFlow as TF, and then Keras. From TensorFlow we will import Keras. These are all the necessary libraries that we require throughout this project. Let's run this cell. Fine. Now the next task that we have to do here, we'll again open that environment here, and here we will create a new folder. Just right click on the environment and click on new folder. Then rename the folder to potato disease. So potato disease. And then you have to paste all these 3 folders, early blight, late blight and healthy, in this potato disease folder. So just paste it, early blight, then late blight, and then healthy. As you can see, now you have all those 3 folders in the potato disease folder. So basically your early blight looks something like this. You can open that images as well in the Google Collaboratory. You can see there are some spots on the leaf. So these are a condition of early blight, as you can see this. And when you check for the healthy leaf, in that case you don't have any kind of spots on that leaf. Basically, as you can see, you don't have any black spots or any kind of spots on the leaf. The leaf is clear. So that's a healthy leaf, potato leaf basically. Let me close the tabs. So as you can see, now that we have all these folders in the main core folder directory, that is potato disease. So what we will do next is we will write here data directory, that is data dir. Then here we have to paste the main path. Now main path basically refers to the main directory that we have, that is the potato disease. Just copy the path of the core folder, that is your potato disease, and paste it here. So this is your, let me write here, this is your base directory. Then after that you have to mention the categories name here. So I will say categories is equal to, categories will be in the form of list, and keep in mind the name of categories should exactly match with your folder names that you have here, early blight, potato late blight. If the names mentioned in the categories list and here the folder names, if they don't match, then basically it will throw an error. So names of the category should exactly match with this folders, and also they will be in sequence. Here the first folder is early blight and followed by late blight and healthy. So in the same sequence we have to mention the categories here. If you mention the potato healthy first in this categories list, and after that if you mention potato early blight, that will basically assume that your first folder is healthy and then the last folder is early blight. So it will basically mess it up. So the categories name should be in sequence. So we will say potato early blight. We basically have 2 underscores here. The first is potato early blight, then after that the next is potato late blight, and the third one is potato healthy. So these are the 3 categories from your base directory. Now after that, what you have to do, you have to write a code using the OS in order to join this categories path to the original base directory. So you have to join these categories to the base directory, and whenever it will connect the potato early blight to this particular path, it will enter the potato early blight folder. Similarly, when it will connect the late blight category to the base directory path, it will enter the late blight folder. So this is how you have to basically join the path and create the path for the image. So for that, we'll say for category in categories. Here you have to say your path is equal to OS, the module that you have already imported, OS dot path dot join. Now what you have to join here, you have to join your base directory, that is your data directory, with the category. Now what is category? Category will be extracting one element from the categories list. So for the first iteration, it will extract the potato early blight name, and it will join that with the base directory, with the help of which it will connect to the early blight folder. So we will join that data directory with category. So this was basically the code for constructing the path. Let me write here, constructing the path. Now after that, what we have to do, if you want to display the image, you can say something like this: for image img in os dot list directory of path. So you will access now the images from the path, and you will say image array is equal to CV2. Now we are making the use of CV2 module that we have already imported here. So you will read that image now. So I am read os dot path dot join path and image. Then after that, you will make the use of IamShow method from matplotlib. Now as you can see, we have already imported matplotlib.pyplot as with an alias plt, and we will make use of that. So plt.IamShow, and here you will pass that image array. Fine. And you don't want to display all the images, you just want to basically take the look at first image available. So you will just break it, and after that break here. Let's run that. So there's some issue here, let me check. So the issue here was it wasn't matching with the original folder name. So the reason was there are 3 underscores here between the potato and early, and even here we have 3 underscores everywhere. Fine. Let's run that cell again, and let's run this cell as well. Now as you can see, it is displaying you the first available image from the early blight. So this is the color image RGB with the channel dimension of 3. Now you can go ahead with processing this color images if you want to, but actually color doesn't matter here. We can easily identify the spots and all the things in the grayscale image as well. And also when you make the use of color images, that is the RGB images, your RAM, your session basically crashes because you run out of your current memory, current available memory basically. So I tried many times using the color images, but my session was crashing, and hence I will make use of grayscale images here. So I will say cv2 dot IamRead underscore grayscale. Let's run that. And right now, as you can see from you mentioned IamRead grayscale here, but it's displaying you the image in the green color from the RGB. It's displaying you in green color. So if you want to see that in grayscale, in the IamShow method, you have to add CMap here. So CMap is equal to gray. Let's run that. So now you have the grayscale image. So one RGB image is 3 times larger than one grayscale image, and hence it consumes more memory, and for that reason I am making use of grayscale images here. Now after that, after displaying the image and after doing this, if you can even check the data for your image, you can say here image array. Let's run that. Show data. So as you can see, this is your data. Now you can find one significant difference here. If you don't make the use of grayscale here, let me remove this attributes from here, and if you make use of RGB images here, then take the look at your image array. Now you can see you are having the n dimensional data everywhere for your RGB images. As you can see, this is n dimensional data. So let me hide it. But when you make use of grayscale images, in that case your size of data is also reduced. Now you have one dimensional data here, as you can see. So this is how the grayscale images basically consumes less memory as compared to RGB images. Now after that, next thing that you have to do, you can check the shape of your image. So you can say image.shape, actually image array.shape. Let's run that. And it's basically 256 into 256, that is 256 by 256 pixels are the images of. But it might happen that all the images in the folder might be of different shape. Like when you take the look at your early blight, it might happen that every image in the early blight may not be of same size, or it can also happen that the images from early blight and the healthy folder are different in size. So for that reason, we have to shape all the images into one generalized size, and I will give that image size as 256. Now it is 256, and I will say that all images should be compulsorily of 256, not more than that and not less than that. So I will say that image size is 256, and then I will create a new array here that will basically resize all the images available in the potato disease directory to this new image size 256. So cv2 dot resize, resizing what? Your original image array with a new image size. Now either you can write here directly 256 by 256, or you can go ahead by making use of image size variable, that is image size and image size. Fine. So after that, then you will display your new image. Let me display one image using the new array now. Then cmap is equal to gray. Let's run that. And as you can see, you are seeing the exact image as it was earlier, because earlier the dimension was also 256 and now the dimension is also 256. But if you change that image size to some very less number, like let me say it to be 50, let's run that. Now you can see there is a lot of glitch in the image. Now you are not able to see the image clearly. When you reduce it more to some 20, you can see now the glitch has been increased to a more higher level. So this is how when you change the image size, the images pixels also fluctuate. So let me make it back to 256. So now you are seeing the clear image. Now after resizing all the images to the image size 256 by 256, now we have to create our training data. So let me write here, creating training data. Now to create the training data, I will make a directory here, or I will make a, and to create the training data, I will make an empty list here of training data. So training data, I will right now make an empty list, and later I will append the data in this list. So here I will say, I will write a function basically. So def create training data. Here what I will do, here we basically have to write the same code that we wrote previously here. So just copy that code, whatever we wrote here from category up till break. So after copying that, you have to paste that inside this function. Now after pasting that here in function, the next thing that you have to do here, you have to add one thing extra here. Now you have to add labels here. Adding labels means 0 for early blight, 1 for late blight, 2 for healthy, like something kind of numeric labels you have to add here to your images. And for that you will say here class num, that is in numeric, you will say categories, that is the original categories that you gave here. These are your categories. So here you will say categories dot index. You will assign index to that category. Fine. So this is what the code for assigning the index to every image from the available folders. And also you will add this thing. You don't require break and I am show here because we are not going to visualize any kind of image here. We are just processing our training data. Now the next thing that you have to do, you created the image array. Now whatever code you wrote here for resizing here, you will copy that code of resizing of new array and you will paste it here after the image array, and then you will say you will append this data in your training data list. So you will say training data dot append. What you have to append here, you have to append your new array, that is the data of your image, along with its labels. So the labels are present in class num. So you have appended your data for every image along with their labels in the training data list. And the next thing is you can paste all this in the try part, that is you can add a try exception code here in order to handle the exceptions as well. So we'll just put here try and we'll put all this code inside the try, and after that we will write here except exception as e, and we won't write any code for exception, we will just pass that. So after that now we have to run this function. So let's run this basically first, and then you will call that function here. So we'll say create training data, run that. So now you have called that function. We are done with that. If you want to check the length of your training data, you can check the length of training data. So this is the length of your training data is 2152. Why? Because you have 1000 images in a late blight, 1000 images in early blight, and 152 images in healthy folder. So when you combine all of them, you have 2152 images in total in the training data along with their labels. Now after that, it's also important to shuffle them. Right now they are displaying the images or assigning the images in a sequential manner. All the images from the early blight first, then from the late blight, and then from the healthy. So it's going in a sequential manner. But you want to shuffle the things. So you will just import random here. Like you want one image from late blight, then followed by one image from healthy, one image from early blight. So you want all the images not sequentially but randomly. So you will import random here, and then you will say random dot shuffle, and here you will say training data. So you have to shuffle from the training data. Let's run that. Now we have to divide our training data like we do in our traditional machine learning approaches, where we put all the input features in the variable x and the target feature in the variable y. So here I will create a empty input list, that is x, and empty target list, that is y. So from this training data, all the data of image will be appended in the x list, and the labels that we have added, that is the class num, will be appended in the y list. So here we will say for features or your input columns, and then the label in training data. You have two columns in your training data. As you know, the first column that we appended in training data was the image array, that is all the data of image in one dimensional, and then the labels in the form of class num. So you are naming this first new array as your features and your class num as your labels here. So in training data, we will say in x we are going to append the features, and in y we are going to append the label. Let's run that. Now we have to reshape our input variable x, that is our images. So we will say x is equal to, now we will make use of numpy here, np dot array x dot reshape -1, then image size. So the image size that we set was 256, and then here you have to mention the channel dimension. Now if you are making use of RGB, that is the colored images, then you will mention the channel dimension as 3. But if you are making use of grayscale images like we are doing, then you will mention the channel dimension as 1. So this channel dimension will change depending upon whether you are making use of colored images or grayscale images. And then you will also reshape your target feature, that is Y. Basically you are not reshaping it, but you are converting the values in the array. Right now when you check the type, why we are doing that? Because when you check the type of your X and type of Y, let's run that, both will be in the form of list. As you can see, X, that is our input data of images, is also in the form of list, and the labels are also in the form of list, but it's necessary to convert the data in the form of array, and for that reason we are writing this code. So let's run that. And now when you check the type of both, that is X and Y, now you can see both the variables, that is X and Y, now are in the form of NumPy array. So this is what we were trying to do. Now after that, the next step that we have to perform is we have to perform data normalization here. So you just, when you mention X, you can see here all this data consists of values between 0 to 255. So this is the this is not a scaled data because it consists of values between 0 to 255. So it's necessary to bring all this data onto one common scale using the min-max scaling. So what we will do, we will convert all these data values that we have between 0 to 255 between the range of 0 to 1. So the value 0 will remain 0, and the value 255, that is the maximum value, will become 1. And every other value between 0 to 255 will now be converted to the range between 0 to 1. So for that we will say X is equal to X divided by 255. So we are dividing all the values with the 255, that is our maximum available value. Let's run that. Now when you display X, now you can see all the values are in the decimal format. We have converted all the values between the range 0 to 1. Fine, let me delete this. Now we will actually start building our model, the convolutional model. So I will write here, building convolutional neural network model. Now to build the model, here I will say model is equal to keras dot sequential, that is we want everything in sequence to be executed in sequence basically. Then here we will say the first layer will be of convolutional layer and followed by a max pooling layer, and then we can stack multiple convolutional layers onto each other. So first we will say keras dot layers dot convolutional 2D. So convolutional 2D. So this is the first convolutional layer that we are going to use, and here first we have to specify the size of filters. As you can see, it's showing you basically all the parameters from the convolutional 2D layer. So the first is we have to specify the size of filters. So let's say we want to add 64 filters here, and then we have to specify the kernel size. Kernel size is basically the size of your filter. So you are going to make use of 64 filters, but the size of each filter will be, you can keep it anything, 2 by 2, 1 by 1, 3, no, not 1 by 1, actually 2 by 2, 3 by 3, 4 by 4, anything. So let me say kernel size is equal to 3 by 3. We will keep every filter size to be 3 by 3. After that we have to say input shape. Input shape. Now what will be the shape of our input? If you say something like this here, x dot shape, let's run that. You can see this is your shape. Now 2152 are the number of images that you have in your input data frame, that is X. But we don't require this. We just want this shape of 256 by 256 and the channel dimension 1. So either you can directly write the 256 by 256 into 1, or we can just say here X dot shape and everything after 2152. That is, we will exclude this and will include every data after that. So starting from 1 and after that everything. So there are two ways. Either you can directly write 256 and 1, or you can make use of something like this. Now after that, you have to specify the activation function. Now activation will remain a ReLU for every hidden layer. So this is your first convolutional layer. After that, you have to add the max pooling layer in order to extract the important features while preserving the important details. So you will say keras dot layers dot max pooling 2D, and here you have to specify the pool size. That is the like you have the filter size, kernel size in your convolutional layer. Here you have your pool size. It can be anything 2 by 2, 3 by 3, 4 by 4. And you also have to specify strides. Now the default stride is 1, that is it will shift by 1 row and 1 column respectively. So I will keep the stride 1 and I will say my pool size is 2 by 2. Fine. So this was the first convolutional layer followed by the max pooling layer. You can add as many convolutional layers similarly as you want. So let me say I will repeat this layer. I will add one more convolutional layer here after this, with the same filter size, and will everything remain same, but now we don't require this input shape here. So this is our second convolutional layer followed by the max pooling layer. So we are just keeping it simple. We will just have this two convolutional layers here followed by two max pooling layers. After that, we will flatten our data. Right now the convolutional data will be in the two-dimensional format, so we have to flatten that to a one-dimensional, and hence we will say keras.layers.flatten. We don't have to pass any parameter into that, just keep that flatten empty. So after that, now we have to build the fully connected dense network here, that is the artificial neural network here. So we will again keep two layers into that. So first is keras.layers.dense, and here you have to specify how many hidden neurons you want in this layer. So let me have 64 neurons, and then the activation is ReLU. Fine. So let me name that actually. So the first, this is our convolution layer 1. Then this is our convolution layer 2. After that, this is our flattening layer. Then this is our hidden layer. And we are just having a single hidden layer here. After that, we will add our output layer. Now in our output layer, we will again say keras.layers.dense, and here we have to specify the number of neurons that we will have in our output layer. Now as you know, we have three categories here into which we have to classify our images. Either it can be early blight, late blight, or healthy. So as we have three categories, we will have 3 neurons in our output layer. So the neurons will be 3, and then the activation function. Now as we are making multi-class classification here, we will make use of softmax activation function. You can go ahead with sigmoid as well, but for multi-class classification, softmax is the best choice. So softmax. So this is the code for our model. Now after that, after building this model, we have to actually compile that model. So here we will say model.compile, and first parameter here is optimizer. So we are going to make use of ADAM optimizer, that's currently the best available optimizer. Then after that, we have to specify the loss function. Now as this is the multi-class classification, we are going to make use of sparse categorical cross entropy. So sparse categorical cross entropy, and then metrics, that is on basis of what you have to evaluate your model. So we are going to evaluate our model on the basis of accuracy. So the metrics here will be accuracy. So this is the code for compiling the model that we built here. After compiling, now we have to fit our model. So we will say model.fit. Then you will pass our input data of the images present in X and the labels present in Y. Then you have to specify the batch size. That is, you have so many images here. You can't pass one by one single images individually to the model. So in what batch you will, so you will pass images in batches. So a batch size can be anything. I will let it be 32. That is, it will pass 32 images simultaneously to the model for compilation. After that, I will specify the epochs. Now always start with less number of epochs, and depending upon the accuracy and validation accuracy, increase the number of epochs. So right now initially I will keep it 5, and then the validation split of 0.1. So this is the code for fitting your model. Now after that you can start running your model. So after the 5th epoch, now the accuracy is 98%, the normal accuracy, and the validation accuracy is 89%. So that's a good thing. Then you can try and go ahead with various validation split values and different epoch values, different batch size values. And you can, if you want, you can also work with color images here. To work with color images, you just have to remove this parameter of cv2.imread grayscale and the cmap gray from this particular code, and also from the training data code. As you can see here, in training data also you have to remove that, and then you have to change your channel dimension from 1 to 3. So when you make this minimal changes, you can go and work ahead with the color images. Reason for not working with color images in this particular code was, when you work with RGB images, in that case you already have a lot of data in itself, and then you have to compromise your convolutional layers. So then you cannot add this many convolutional layers. You have to delete one, and also you have to reduce the size of filters, because if you keep it as it is, then basically your session crashes and you run out of your system RAM. So that was the reason. And so, yeah, so this was the project for potato disease classification using the convolutional neural network. That's it for the video. Thanks for watching.